Hello and welcome to Chapter 5, Section 4. We're starting with dividing decimals. Now this is going to be a review of our long division skills. It's almost exactly the same as long division. It's got one or two extra steps. So let's start with 5 into 18. 5 goes into 18 3 times. 3 times 5 is 15. Subtract and we get 3. And we don't get to stop here with decimals. With decimals, what we're going to do, we're going to put this decimal and we're going to add a 0. This is called annexing zeros. And this means that after this decimal point, we can put as many zeros as we need in here in order to get it so that we can have as exact an answer as possible. If we put a decimal down here, we have to put that same decimal here, and this is where columns really become important. 5 goes into 18 3 times. 8 is the last digit I use. That 3 is to go right above the 8. If we just throw this 3 up here anywhere, we might end up with an extra placeholder. We need to make sure that our columns are exactly where they need to go. Now, if I annex this 0 here, then I'm going to bring it down next. And 5 goes into 30 6 times. I'm going to put that 6 right above this 0 that I'm using. 6 times 5 is 30. Subtract and I get 0. And now I'm finished. 5 goes into 18 3.6 times. 3 6/10. What happens if I've got a decimal already in my number? Let's say I've got -4 that goes into 12.3, 12 3/10. I'm going to start by putting that decimal right above here where it goes. And I know that my answer is going to be negative because a positive divided by a negative is a negative. So we're going to start with 4 doesn't go into 1. 4 goes into 12 3 times. And I'm going to put that 3 right above the 2. 3 times 4 is 12. I subtract, I get 0. I bring down my 3. 4 goes into 3 0 times. And 0 times 4 is 0, and I subtract and I get 0. I'm going to annex a 0. And I'm going to bring that 0 down. 4 goes into 30 7 times. 7 times 4 is 28. 30 minus 28 is 2. And I'm going to annex another 0 and bring that 0 down. 4 goes into 20 5 times. 5 times 4 is 20. I subtract, I get 0. This is my complete answer, negative 3.075. What if the decimal's not in this section? What if the decimal's in the divisor? I can't have a decimal in the divisor, not allowed to. So I need to, essentially I'm going to multiply both of these by whatever I need to get that decimal gone. I'm going to multiply them both by 100. But I'm not really going to worry about that because all I'm really going to do is say I'm going to move the decimal over 2 times to get rid of it. But if I move that decimal over, I also have to move this decimal over 2 times. And I'm going to add these zeros and I'm going to put my decimal there. And then I'm going to get rid of these because they're confusing. Now I no longer need this 0 here. I can leave it there, but I don't need it there because this now is a 25. And when I multiply both of them by 100, it doesn't change anything about how many times this chunk goes in this chunk as long as I multiply both of them by the same number. As long as I move the decimal the same number of times each, it's all fine. So, how many times does 25 doesn't go into 5, 25 goes into 50 2 times. 2 times 5 is 10, 2 times 2 is 4, and 1 is 5. I subtract. I bring down my 0, 25 goes into 0, 0 times, and then I have my decimal point. So 25 goes into 500 20 times. So what happens if we've got both a decimal outside and a decimal inside? Well, I need to be able to move this decimal out of here. I can't have a decimal here. So I'm going to move this decimal over once. So I'm going to move this decimal over once. And I'm going to put it right there, and I'm going to put it right there, and now this is gone. So now I've got the problem 5 into 32. 5 goes into 32 6 times. 6 times 5 is 30. Subtract and I get 2. I'm going to annex a 0 so I can bring down a 0. And 5 goes into 20 4 times. 4 times 5 is 20. Subtract and I get 0. So it's just like long division. You've got to deal with your decimals And you've got to do that first, and then you've got to make sure it's done at the end, and then you're done. It's all pretty much the same thing. You never have remainders. So you're going to take this either until you get a 0, and then you're done, or if it says to like the third decimal, then you can stop. If you've got a 7 out here, you know 7 is evil, and so it's going to keep going and going and going and going and never going to stop unless it's exactly divisible by 7. So now I'm in the book on page 285, and we are dividing by 10, 100, 1,000, all of those. If we have a number, whether it's got a decimal point or not in it, when we're dividing by 10, it needs to be just as easy as when we're multiplying by 10. When multiplying by 10, you just keep adding zeros. And when you're multiplying by 10 with something with a decimal point, you're going to make it bigger by moving that decimal point to the right so that this digit's getting bigger. When we divide by 10, we do the same thing, but we're going to make the number smaller. If we divide by 10, I'm going to move it over once. And so now it's 0.04. It's 0.04 if you're on the computer. If I have 67, a number that does not have a decimal point, I know there's an imaginary decimal point right there. And so if I divide by 10, I'm going to move it over once. If I divide it by 100, because it's got 2 zeros, I'm going to move it over twice. If I divide by 1,000, I'm going to move it over 3 times, and I'm going to have that placeholder there. So dividing by 10, 100, and 1,000 is a lot like multiplying. It really just means you move the decimal over and you move it the same number as you've got zeros. Okay? So let's say we're going to divide these two numbers, this one by 10 and this one by 100. Let's have you try it now. So pause the video, write these two down, try it yourself, and then push play again, and I'll walk you through it. Okay? Okay, so I've got 32.89 divided by 10. I'm going to make this number smaller by 10. I'm going to move the decimal point over 1, and it's just going to be 3.289. This one I'm going to divide by 100. I'm going to move this over 2 times because I've got 2 zeros. So now I've got 5.262. All right? So on page 286, we talk about dividing by 0.1, by 0.01, by 1/10, by 100th, and by 1,000th. And so we want to know what this looks like without having to do a big, long division problem. There's 2 ways to look at this, and you've got to pick the way that works with your brain. If I'm saying 0.123 divided by 0.01, that's the same thing as saying this, 0.01. And I know that I have to move this decimal over 2 times, so I'm going to move this decimal over 2 times. And my answer is going to be 12.3. It's 12.3. If this doesn't work for you and you're a fraction person, try this. I'm going to divide 12.63 by 0.1. This is 1/10. This is the same as 1/10. And if I divide by 1/10, I actually am going to multiply by 10, because when I have a fraction, divide by a fraction, I'm going to flip and multiply. So I'm going to make this bigger by 10. And now I have 126.3. Our next section, and here I'm on section B, which starts on page 286, is solving equations. And so here we've got decimals that we're multiplying to our variable. And anytime we've got decimals multiplied to our variable, we are going to divide both sides by the number connected to our variable, because we want this by itself. So we're going to do the opposite of this. And by dividing by this, these things both go away. But I'm also going to have to divide this by 0.25. Now here, we're going to have to do a long division problem in order to solve this. So we're going to set it up, because this setup doesn't really help us in decimals. But it does tell us what we're doing. So we're going to set up a small 0.25276.4. I'm going to move this decimal over 2 times. I'm going to move this decimal over 2 times. Put my decimal there, put my decimal there, put a placeholder in. Now this is all gone. 25 goes into 27 once. 25 subtract 26. 25 goes into 26 once. 25 subtract 1, 4. 25 goes into 14 0 times. And I'm going to bring down my next 0. 25 goes into 140 5 times. That's 125. Subtract. And I get 15. I'm going to annex a 0. And 25 goes into 150 6 times equally. So it's labor intensive, but we are almost to the chapter where you get to use calculators. So just get through this last bit of arithmetic and it'll be all good. There are more examples on pages 286 or 287 if you need more practice in there. And then we have order of operations. And with decimals, it's just the same as all the other order of operations are. We just need to be able to work out what it all means and have a little experience. And I forgot that. I'm going to put that there. So we're looking at 25 hundredths squared times -1 plus 0.08 minus 0.0274. So first thing I'm going to do is I'm going to work in my parentheses. So I've got a -1 and a positive 0.08. These signs are different, which means I'm going to subtract. And I'm going to do biggest minus smallest. So I'm going to do 1 and I'm going to stick a couple of zeros on there. Minus, because I'm subtracting, 0.8. I'm going to borrow from here. I make that a 10, I make that a 9, and that a 10, and I have 0.92. And my biggest one wins. I have more over here than I have over here, so my answer is -0.92. Next thing I'm going to do is going to figure out what 0.25 squared is. That's going to be 0.25 times 0.25. 5 times 5 is 25, 10, 12, placeholder 2 times 5 is 10, 2 times 2 is 4 was 5, and I've got, that's a 2, that's a 6, 1, 2, 3, 4, 1, 2, 3, 4. I've got 0.0625 is this. So now I'm going to get all of my arithmetic out of the way and erase my answers. That's awesome. 0.0625 times -0.92 minus 0.0274. So I've got a multiply and a subtract. I'm going to do the multiply first. So this times 0.92, and that's a negative. 2 times 5 is 10, 2 times 4, 5, 12, 12. And placeholder, 9 times 5 is 45, 18, 22, 54, 56, 56, 0, 10, 5, 7, 5, 1, 2, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, point 0, point this is big. And I'm going to subtract from, and this is negative, and if I subtract from a negative, I'm actually adding these numbers together. So I'm going to go ahead and put this over here, 0.057500, so I can drop those. And I am adding these two negative numbers together, and my answer is going to be negative. 4 and 5 is 9, 7 and 7 is 14, 8, 0. This is my final answer. So, order of operations is just as ugly any way you look at it. Good luck. We've got one word problem in this section, and if you look at example 14, it's asking you to find the average. So you're going to look at the number of residents per square mile in the box on page 288, and you're going to find the average, which means you're going to add all those numbers up and you're going to divide by 6, and the example is pretty well set up there for you. So you don't have a lot of word problems this time, but it's going to ask you an average. So good luck, and I will talk to you next about 5.5, which is fractions to decimals. See you then.